Hi everybody, Simon Whiteley here. Welcome to my latest video. Today I've got a very special guest with me to talk about system safety engineering and his experience. So round of applause for TJ Candy. Say hello, TJ.
Thank you, Simon. No, it's a pleasure to come on onto this broadcast. I appreciate you and I have chatted before on the subject of system safety, and I'm happy to be able to bring this and exchange information with a fellow safety professional on some of my views on system safety.
Oh, it's fantastic. I'm really excited to hear what you've got to say. And I'll put your slides up on screen if you'd like to just give a bit of an overview of where these slides have come from and where you presented previously.
Sure. No, that sounds very good. So really my title of what I'm talking about today is system safety, a profession in crisis. This is really just my observations from my career. I recently retired last year from after 43 years in the aerospace industry and 20 of those years, roughly 20 of those years as a system safety professional. In addition, for the last 4 years, I've been a system safety instructor at the University of Southern California, Viterbi School of Engineering, Aviation Safety and Security program. And with the exposure to really system safety professionals, both new and experienced around the world, some common threads had pulled on me for a long time until about 3 or 4 years ago. I had kind of a rolling epiphany that led to this presentation that I made last month. I made it at the International System Safety Society summit and training meeting in Austin, Texas, and I had a great response to it. And really, that's what led me to, want to have these materials really presented in a question and answer, a podcast format. So without the restrictions of time that I had there, and I've given this speech in another forum with it a little more abbreviated. So I'm looking forward to the opportunity to talk about it a little bit more at length, to expand on some of the things as to why I think the system safety profession is a profession in crisis. And while I don't claim to have the solutions, but I certainly have a perspective that it would really be good after this is done to get perspectives from other safety professionals to where they agree or disagree, or where we might have some common work that's going on with that. Um, so I'd like to begin the first slide. The next slide, I should say. So this is a quote from a gentleman by the name of William Steiglitz, and he wrote a paper back in 1946 called Engineering and Safety, and he made some foundational statements that really, based on my background as both an engineer and a safety professional, kind of created a vision, even as early as 1946, that the safety discipline and profession was similar but distinct from the engineering profession. And so this quote kind of puts something that I wholeheartedly believe in, and it's something that maybe needs to be reinforced today. And what I'm really going to talk about is looking at that era, the post World War II era, as kind of foundational to the modern system safety profession and process that we know and use today. So the way I want to present this materials is in this format, a series of questions, who, what, where, how, and summaries and conclusions. But really, this is based on my observations from my experiences and the commonalities that I noted, uh, really that come from the 4 years of teaching. And I'll talk a little bit more about that in detail. And really, the premise of my speech is that, with the crisis that we're in, it can really be looked at as an erosion from what we learned in the very nascent era of system safety in the post World War II era. That there was a standard or a methodology that came up with an approach that in the intervening years from then till now have eroded, and I'll talk a little bit more about that. So on the next slide, I just want to give who am I? Like I say, I recently retired from GE Aerospace after 34 years there. You could almost put my career as half in engineering and half in safety, although engineering is both engineering and IT. I actually was a computer science major at Michigan State before I transferred into the mechanical engineering degree where I got my bachelor's in 1981. Interestingly enough, the day that Ronald Reagan got shot, March 28th, 1981, I was sitting in the HR office and got the news that Ronald Reagan had been shot, and that was my first day of professional employment. And as I said, I retired last year in 2024 uh, with that experience. But my primary engagement, my exposure really in that whole 43 years was in the realm of military gas turbine engine development and sustainment. It really was a great challenge in engineering. It gave me a great engineering background. But when I transferred into the safety department back in 2000 and I think it was 2023, um, my worldview changed as I see now the system from the safety perspective. And what I did once I got into that group, I ended up getting my system safety certificate from USC back in April of 2016. So I went through the courses, and really that helped to expand my understanding of system safety. If you have training inside of your business, that it tends to be a little bit self-contained, and being able to go to USC and get the wider range and wider perspective on system safety was incredibly valuable to me. And as I say, in 2021, I was invited back to become an instructor with Dan Strube, who's the course manager for the system safety course. He works at safety out at Vandenberg Air Force Base. And Tim Young from U.S. Air Force, the research labs, the three of us teach the course together, and that's since 2021. And I did start a consulting company back in 2024, shortly after retiring, and where I can continue to want to try to help the industry. So that's a little bit of my background. I think the takeaway from this is the fact that when you look at the origins of system safety, the system safety came out of the engineering function. So I've got to see safety from the engineering side, and I've got to see engineering from the safety side, and that's played into what I've seen and today. So let's go ahead and go to the next slide. Um, so this is just a snapshot of the exposure that I've had since I've become an instructor at the University of Southern California. Actually, these numbers have bumped up. I did another course with NavAir 3 weeks ago, so the numbers are up a little bit higher. But the bottom line is there's really getting exposure to system safety folks from around the world, and again the commonalities that came out in our conversations is really the basis where I came to the conclusion that the problems that we face in industry here in America are the same around the world. And I really feel the need to make a disclaimer at this point, because when I talk about crisis and system safety, I want to not confuse or make any kind of negative light on GE Aerospace. The problems that I talk about are across the board. GE Aerospace was a fantastic employer. They gave me the freedom to really start from scratch on the development safety programs that I work. They gave me the freedom to experiment and try different things. And once I did come up with the safety process, they invited me, and I did. I wrote the design practice for military system safety development programs, which is being used today. So a shout out really to GE Aerospace for really is keeping with their mission, developing the future of aviation. I believe what we learned there, it was valid, and the fact that I was invited at USC and been able to spread those learnings out to the industry is a testimony to GE helping with that. So I want to make that right up front. But really the point here is that the problems that we've seen, that I'm going to talk about in a little more detail when I talk about what crisis, really are based on a perspective that's really, I believe, global. And really the next slide just reinforces that. I did have a background in IT, and so when I started working development safety programs, I noticed we didn't have a tracking tool that we could use that was viable for development programs. And so I really started from scratch with that. I worked that all the way through the time I put 17 years there. The way I tell my students that I say I spent 17 years locked in a dungeon with nothing but Mill Standard 882 to keep me warm. So I developed a very unnatural relationship with Mill Standard 882 in the sense of being able to look at it, try it, and I'd heard a lot of criticisms and complaints about 882, and over the time I had to really apply this to primarily the engine programs are directed at the F-35 program. Um, because I was in that so long, I was able to find out really what I think is the intent of 882 beyond just looking at that as a cookbook for system safety. It really is a brilliant, brilliant document. I've come to understand the problems with it, but I think the difficulty in people applying those standard 882 is one of the reasons for the erosion and why really there's other standards that have developed that people have worked that has been, in response to people seeing it as being difficult. What I came to understand is that, it takes an expert. The movie Ratatouille, where anyone can cook. Anyone can read 882 and come with a safety program, but it takes someone with training, experience, and really a passion for system safety to apply it and apply it correctly. And when it's done correctly, it's a fantastic approach to system safety. Um, so really, this background, I come into this discussion I believe, a solid engineering background. I do have a patent that an engineering patent for a fuel injector while I was in the combustor design group. So, I have an engineering background and a safety background, and that's really where it comes together to talk about this crisis. So let's go to the next slide. So what is the crisis? And I've got some pictures here. This is just kind of, I don't think anybody would argue that there's a crisis in system safety from the standpoint of there's a lot of problems going on, and a lot of very high profile events. Um, One of the things that I'll say my rolling epiphany was the fact that, when we looked at these accidents and we received, root cause, why did this happen, and what do we got to do to address it? What I noticed was we weren't going back to we know this part failed, but where did the safety process itself fail? In other words, why didn't we find that? Because the safety process, if applied, gives you the opportunity to find what I call discoverable hazards. And I'll talk a little bit more about that. But one of the outcomes of the Mill Standard 882 process with the 200 series tasks of analysis is that you understand what your risks are. What are the causal scenarios that can lead you to the undesirable events you're trying to mitigate? And so if you do have that event, in my mind, it was the idea that you should have a place in the process that says, well, why didn't I find that? Not to place blame, but to understand where can I improve the process for the next time, or where can I, find out where I might have made mistakes that I can correct. Those kind of things that Simon, I know you know very well from the stamp cast process when you look at accident investigations and really try to milk out everything I'm supposed to learn from these events. So obviously you see these things that are very well known to you. Let me talk a little bit more in detail about that. So one of the things we understand is accidents will happen, right? One of the things I've written a LinkedIn article about it, and I mean, hats off to SpaceX for the things that they've done. They understand takes risk, and accidents will happen. I did kind of get, as a safety professional, when especially after a few launches and you see the explosion and everybody cheers, and it's kind of like, well, I understand rapid unscheduled disassembly, but I think in a safety professional, something that is like the fingernails on a chalkboard reaction, because it's like, yeah, we certainly want to understand that there are risks in doing things, but the idea is that we want to avoid the failures and things that are happening. One of the other things that's evidence of this crisis, and this comes from exposure to a lot of the students in the class, when we talk about the system safety team, the safety team itself, a lot of times is called into the safety process late, and by late, I'll talk a little bit more about what the definition of late is. But really, when you look at the lessons learned, and I'll talk a little bit more about the ICBM program, the idea was you want safety engaged as early as possible, and that includes even at the conceptual level. But it does take experience to contribute in the safety realm at the concept level. So if you have someone who doesn't have a lot of experience, I don't know how helpful they'll be in the conceptual level. But the idea is that, you know, the reality for many reasons is the safety team is often engaged late in the design process. One story I like to tell from the class was a student that the safety team was contacted within months of the product seeking, and this was outside the country, but I'm sure it happens inside the U.S. as well. But they got contacted months before the certification documents, the safety certification documents were due, and so they gave an estimate to the team of how much effort it would take to do the safety effort, and then how much to write the report. And straight faced, they were asked, well, how about we just fund you to write the report? And that really speaks of either a belief that the safety process doesn't work, or it's just a bureaucratic exercise, and that really it's really not a right view of safety in my mind. Another thing that's contributing to the crisis that we have is what I call the 10-year rule. So when I first applied to system safety years ago, 20 years before I retired, I was interviewed by someone who went on to become the VP of engineering. And one of the first questions she asked me was, how long are you planning to stay in system safety? And I said, the rest of my career. And she said, that's a good answer. And she went on to explain that if you were to tell me you're going to be here for 3 or 4 years, you really should move on and not take this job, because it's going to take 10 years to get useful work out of you. And it really struck me, because as time has gone on, and as I've went on with my career, which I did stay for 20 years, so I didn't you know get out too quick. But and as I've talked with other students, there is this thing about the 10-year rule that has credence. And what happens is when as a safety professional, once you've been around a while and you start interacting with other safety professionals, you can almost tell who's been there 10 years or more, because there's just a vernacular that develops. There's like with any discipline, you can tell that. The enemy of the 10-year rule, in other words, if you assume, and I think it's accurate, that it's a 10-year pipeline, once you come into the safety department, like she had said, it's going to take 10 years to get useful work out of you. You really have to look at that as a long-term deal. And the reality of business today is people are moving a lot. And what I call on that slide the poaching problem. One of the things has like I trained a large number of people both at GE and at USC, and I get feedback about really good and talented folks that get poached out of the safety organization. And while that's okay and understandable, and it's a reality of the business, in order to keep a viable safety organization, you really have to account for that in your training. That it's going to take 10 years, and that's hard. And so what you end up with is really safety departments where the aggregate range of training and experience is something less than 10 years, and that's a problem, because it takes that long to get experience with the tools, with the processes and things like that, so that you can lead a safety effort. Another challenge to the crisis is the great statement. The great thing about safety standards is there's so many to choose from, and hopefully the irony of that strikes you. But it is true. I mean, obviously, I believe Mill Standard 882, which came out in 1969, was kind of the standard that everyone kind of comes out from. But you see a lot of different safety standards, and there's talk of replacing Mill Standard 882. There's talk of a commercial standard version of it. There's, the idea is that we really should be working towards a single standard that the industry recognizes, and unfortunately different industries recognize different standards. One of the other enemies and the things that happen in terms of contributing to the crisis we have is, and I'll talk about it later, where sometimes system safety people are their own worst enemies. When you have some blind bureaucratic, regulatory compliance to system safety, rather than really understanding what you're doing or the fundamentals of system safety. And let me say this: blind compliance to safety regulations and specifications is absolutely way better than not. So I don't want to cast too much aspersion on that. But I will say that really a lot of times things that are implemented are kind of in excess, if you will, of what's needed, because every program is different. We write Mill Standard 82 is really written for a wide range of products, for aerospace and for marine, and any Defense Department procurement really falls under that. So when you look at a spec or a standard or anything like that, there's usually a context that you have to work with and understand in order to apply it correctly. So that in those cases, sometimes people, I've always heard this statement, nobody's happy to see safety, and a lot of times it is because some folks come in very bureaucratic, and there's, I mean, like I say, there's a goodness to that, but sometimes when you push it too hard, I think probably the Titan submersible is the best example of that. I mean, I don't know what the experience was of the gentleman that ran that organization, but if you look at the quotes that he had, it was almost a confrontational or really hostile view of the safety function that led him to take chances. And as a result, obviously he paid the price, and unfortunately his passengers did as well. But, and I'm not excusing that, but by the same token, you can see where if his experience was these folks that were operating as the safety experts and coming across him with a hammer and not being able to explain from the standpoint of the fundamentals why this needed to be done, well, then maybe that's why he threw the baby out with the bathwater on that one. The other reason we have a crisis is right now software is, and it has been for a while, a very important part of safety, and how the safety teams and the software teams interact. We've had a functional interaction before, but as software gets more complex, as software has a lot more uh, opportunities, I'll say, to contribute to safety events, the understanding of things like the software criticality index and how the system safety team should relate to the different levels and the testings, that harmonization is still something that's being evolving in the industry. So that's kind of contributing to the problem. Another thing in the system safety crisis realm that I think is important is questioning the role of the C-suite or the corporate, the CEOs, the high level. What is their interaction with system safety? And to this point, most companies, GE included, and many of the others are absolutely spot on. There is, system safety is job one. The focus and the messaging is absolutely rock solid. I haven't heard of a single organization that would say anything less than that. But with the recent grilling that Dave Calhoun took from Boeing in front of the Senate committee, the question of what should a CEO or C-suite understand about system safety, and really that needs to be settled to a certain extent. And I would put forth from my observation that really the CEO or the person in the C-suite is the health monitor of the safety organization itself. And I'll talk a little bit more about that, because really that motivation for safety definitely needs to go to everybody in an organization from the bottom to the top. And I think actually businesses are doing a great job of that. But as far as the care and feeding, I guess, of the system safety organization, I think that's a role that I would like to see more CEOs take on and understand, to help the system safety organization to be ready to deal with the things that they have. And another reason for the crisis is, the term safety expert is tossed around very indiscriminately. And part of that is, the industry really hasn't had a great settling on standards. There has been attempts, and obviously even at USC, we have a definition of, when we give a system safety certificate out, what we believe an expert is. but you have the Board of Certified Safety Professionals. You have other organizations that are conducting training in safety, but it's kind of individual. And I know that the International System Safety Society is working a credentialing effort to try to standardize in the industry what a safety expert is, what are the minimum levels. So, for the absence of that, really, I think anybody can stand up and say, "Well, I'm a safety expert," and people would accept them at their word because there's really no other check other than the knowledge that this person has been around for a long time, or it's in some cases it's someone very, very new to safety. But really, the crisis, if I could put it in a nutshell, is that when we look back at the origins of system safety from the ICBM program, where we said we need independent oversight as early uh, as the in the design process as possible. Really, it created a separate organization that was separate from engineering. And I would say the problem is I think it's been subsumed back into the engineering function, and I'll talk about that. So on to the next slide. One of the things, oops, I'm sorry, Simon, one more slide, because I did talk to that already. So this, the explanation number two is that, when I was in engineering and we would come up to a problem and we'd be working it and we'd come up to a solution. And when we presented the solution, sometimes, you had disagreements on it. And I always said that we would say you can't fight physics. When you had a problem and it was temperature or stress or other related, the numbers were the numbers. The physics were fairly well understood. And so you can't fight physics. And I think in terms of system safety, there are physics that are foundational, just like the Bernoulli equation and Navier-Stokes and all those things. It's written in the standpoint of in Mill Standard 882, Figure 1, you see there is that really system safety is about you need to have a program that you identify what your hazardous scenarios are, you convert them into causal scenarios, and then you examine those causal scenarios. You conduct analysis to discover what they are. Then once you identify those causal scenarios, then you take it through a safety process to understand and assess the risk to determine what corrective actions that you need to take place, complete those actions and document those actions, and then provide the evidences of that to the regulatory agency. That, to me, that's kind of like the physics of safety. The if you look at Mill Standard 882, it's a very structured approach. You have the 100 series management, you have the 200 series analysis, and then you go into the 300 series test and analysis, and then the final, the 400 series, the verification. That process steps you through what I think is the basic physics of safety and what every safety effort should involve at some level. Um, so the idea is, these different things that I'm talking about, really the fact that we're not getting agreement on these things and these things that are happening in the industry, things that I've heard about, all these things have led me to this statement of why I believe that the system safety profession is in crisis. Okay, so let's go on to the next area and talk about the next slide, I should say, and talk about what is the crisis. The idea is that the safety events are really a lot of times we've heard it over and over again that really people aren't following established safety practices. The incident where the helicopter was outside of the range that had been set before. The uh, people, runway incursions, midair, close encounters and those kind of things. Those aren't a lack of understanding what the safety risks are. It's really just a matter of, people not doing them for one reason or another. And that's why we have a crisis. Also, something I alluded to earlier, when you look at an investigation, a lot of times it stops at the first root cause and we go and address that and try to fix it. And the problem is that I think it needs to go further to go back to where in the safety process should we have identified that? And how do we make sure we don't do that again? How do we refine and continually improve the safety process rather than just fixing this process on its or problem on its own and letting everything else go? And the other thing too is the safety teams are constantly operating in what I call a triage mode. I liken it to, if your safety department looks like an ER and not a doctor's office, where you're only responding to crises, then really that really is a problem for developing new programs, because really developing new programs, you need to be following a methodical process. You need to have the time to work these things. You can't be in a triage mode in a development program. And one of the compounding things that happen when you get in a triage mode is now the training starts moving to the back. The collaboration and the ability to work through these things gets pushed back because of the needs of things, the needs of programs. We have a lot of understaffed programs. And I know in the industry that's normal. Everybody's operating on a shoestring, but I think, if safety is job one and is important, then really they should have a little bit more focus and not be operating in such a challenging mode, I'll say, that keeps them constantly in a triage mode. Okay, on the next slide. So I'm going to talk about, when I talk about a crisis, what's the standard? Where did we start at? Where is it? You could talk about safety in the class. Dan Strube talks about going back to the Code of Hammurabi, where they had, if you build a house for someone and it falls on them and dies, then you get killed, and if it kills their wife, they get to kill your wife. The consequences of trying to enforce a safety mindset, all the way up when we got to the ICBM program, when we had kind of nuclear annihilation at our backs, trying to develop a system to launch these, and really in the early 50s and 60s, or yeah, when they tried them, these spectacular launch failures that happened. And really that's where the I will say the pioneers of system safety got together and decided that, look, the reason we have a lot of these problems is that, the people who are making the decisions, the project engineers, the systems engineers, and those that are burdened with a very, very difficult task of balancing things like performance and cost and weight and all these other things, including safety and other considerations, they've got to balance those things. And there's the potential that safety can sometimes get pushed a little bit to the side or not get a seat at the table. And so what they decided was, let's create an independent safety organization with oversight of all the critical design decisions so that safety does get represented in those decisions. And they added as early in the design process as possible, or as before they got to the launching pad, as was their words. And the need for that was fairly evident to them. So really the experience from the ICBM program and bringing an independent safety oversight on critical design decisions early in the design process really led to the creation of a system safety process, in which ultimately led to MIL Standard 882, which was originally released in 1969. And what that created was, rather than a reactive system safety approach, but a proactive or even predictive approach to safety. In other words, what they found was you needed to do some form of analysis, and multiple forms of analysis, to be able to understand what your risks were so that you could address them before the product was even created. The Rev C of MIL Standard 882 was my entry point into that standard. I know that some of the earlier versions had issues and things that people responded to, but really, ever since Rev C, the definition of how to deal with, or at least a framework of how to deal with things like software and verification, and how it hands off into the regulatory process was really laid out. So going on to the next slide, what happened as a result of those learnings is a matter of record, and it's talked about and lauded, and enough can't be said of it. In the 60s and 70s, the accident rates, particularly in commercial aviation, just dropped. And so there was to my mind, that's why I call the ICBM era the fulcrum of safety, because really after that fact, because of what we learned, there was a great benefit that continues to this day. However, uh, what we see in specific events, and I'll talk a little bit more about this, is you see that it's kind of leveled off a little, and actually to the point where we maybe we're getting back a little bit to that trial and error method, which was what preceded the ICBM program. But definitely in the 70s, 60s and 70s, we saw a lot of benefit. So on the next slide, um, what's happened since they came up with that process and approach that was reflected in the formation of the system safety profession we know today, and procedures like Mill Standard 882, is that independence, that independent organization, which at first is designed to be separate from the engineering and project functions, slowly over time has gotten pulled back in. Probably most of you are aware of the Challenger disaster back in, I believe it was 1980, 81, when the shuttle was launched. Unfortunately, it was a cold day. They launched, and they experienced a failure of an O-ring on it, which ultimately led to the hot gases from the solid rocket boosters escaping and eventually destroying the solid rocket booster and the shuttle itself, and losing the lives of 7 brave astronauts. On the lead up to that, there was, on the morning of the flight, or prior to the flight, when they knew that they were going to be launching in cold weather, there was a sign-off process that was supposed to take place so that everybody, approved that the launch could take place. An engineer from Morton Thiokol named Alan McDonald had previously written a letter to NASA indicating that launches shouldn't be held below a threshold temperature, at which this was below. And so he refused to sign off on the launch. Uh, Ultimately, some other executive at Morton Thiokol signed off on the launch, and the results unfortunately happened. It's a case in my mind where the safety process was subverted, if you will, to when the safety expert refuses to sign off on a launch. That launch probably should have been scrubbed. But in the intervening years, there's been other events where the safety process, they knew there was a problem, and it wasn't given the right emphasis, and unfortunately a mishap ensued, and then the results have happened, and that seems to be happening a little bit more when you look at things like the auto drive of the cars, and the unfortunate accidents that happened with SpaceX. While I'm sure they're part of the risks that happen with advanced development, but these are things that contributed to my vision of why I think there's a crisis today, and really it is summed up in the loss of oversight. That the safety function, if it's moved back into engineering, you're going to be back doing what happened before you implemented that system. So we, the question I think for the businesses to ask is my safety function truly independent, right? If there's not a right relationship, if they aren't truly independent, if their funding comes from engineering, or if they're, how they're set up, there's a potential that there could be, that the independence, I should say, is not being honored. Um, and really, the other thing is, if we have if the safety effort is really just compliance to standards and procedures, you're really vulnerable to what's new and what can come along. Because when you look at it, standards and procedures are really what's I call corporate memory from the regulatory agencies. Hey, we've learned this in the past, and what we encapsulate in our standards and procedures is don't do that again. And this is what we do to safeguard it. And which is great if you're not developing new technology. If you're using the same technology, well, that's a great way to manage risk. However, you become vulnerable to anything that's new. And that's a problem, because in order to understand your risks and to the new things that can come along, you have to have experience. You have to have, back to that 10-year view, you have to have access to someone with a lot of experience to be able to understand what my risks are. And really what's happening across the board, and as I talk to different people, is there's really a decreased dependence on trained and experienced safety professionals. But the realities are that they don't have anybody else that can do it. So you take someone out of the systems organization or the engineering organization, say, okay, you're safety now, and set them off. That's the reality, is that happens, but there's a consequence to that. And really, as I call it, risk can be left on the table. Okay, so let's go to the next slide. And let's talk about you know, how did we get here? And I really point back to the ICBM era where the system safety experts, the founding system safety experts, talked about independent oversight early in the design process and structured program. Really is where we've deviated from, and to the measure we're not independent, to the measure we're not using structured program, structured safety efforts, to the extent that we're not getting them engaged early in the process, is to the extent we're not following what they said. So really, it's understandable to a certain extent why we find ourselves in this place. Cost is king. One of the unfortunate observations that I have is that oftentimes engineering sees safety as a competitor or as I don't know, going back to that, nobody's happy to see safety. But when I had my first safety review of hardware that I had designed before I got into safety, I remember being a little bit offended when the safety person came by because I thought, what are you saying my stuff isn't safe? As we say, you call my baby ugly, I had that defensive posture. And I think it's a natural, conflict that happens because, the engineer obviously feels like they're the best expert on that, but the system and the safety person may or may not have that same degree of technical expertise, but it undermines a little bit the idea that no, I'm there to provide oversight. I'm not there to critique the design as much as I am to oversee the safety aspects of that design and make sure we're in agreement. But the reality, and when I was in engineering, I thought, well, I could do that system safety stuff, and they probably could. They're systems engineers, people coming into safety can do a really good job. The problem is the expertise and the oversight that's needed. It isn't that they can do it. It's that you actually, what they learned in the founding fathers, you need that separate organization looking at that. And one of the big problems too it's been true since the very beginning is that cost avoidance isn't allowed as a substantiation for the safety team. In other words, if you can't take credit for an accident that you prevented. And it may have saved the company a lot of money. It may have saved the money, the money in lawsuits and all these other things. But you can't use that as saying, well, let's fund the safety team so we avoid those. That's something that really has been a problem in the industry. And if it did, I think there would be no problem with the training and the funding and staffing for safety efforts. But unfortunately, they can't use that as a substantiation, even if it does have a basis in fact. Another key thing that leads to this problem, and this is true of safety experts in both the development and the operational support phase, 30 to 50% of your time is on unplanned actions. If you staff and fund your safety team to planned efforts that you have, you're probably going to be 30 to 50% underfunded, and you're going to be back in that triage moment because you're going to have stoppages that come because something comes, stop the presses, safety stand downs, things like that. That stuff happens. And the net result is that you end up many times doing things that are unplanned. And unfortunately, on development programs, they kind of suffer the most from that because while they're off not doing the planned activities, well, the time goes on, but they still have to go back and try to backfill that activities. And sometimes what happens there is that, some analyses maybe don't get completed as well as they were. And so you end up with, a higher residual risk because you really didn't have the staffing to do that. Um, I had a very pointed conversation with someone one time when they were explaining to me how understaffed their organization was, and in the safety department, and they didn't have the money to train them and things like that. And I said, well, if you believe the safety process is just a bureaucratic check the box, we're probably okay. You're saving money. But if you really believe that the safety process works, saves lives, saves equipment, and saves people, then you are taking risk on by not having a viable safety program. So I think the somehow, I know there's no magic pill to this because it's going to take time and money. There's just no other way to look at it, and those things are difficult to get right now. But the question goes back to, do we want our safety effort to be as robust as we can. The last bullet here is that sometimes safety professionals can be their own worst enemy. And I say that a little bit tongue in cheek because one of the things that's true is safety experts, because there's a wide range of people who can call themselves safety expert. The other part is that there's a view of safety that we have based on our experience. Like I said, I'm gas turbine engine, right? And so my experience is largely gas turbine engine. For those that are in automotive, it's similar process, similar things, but the terminology we use for the same things, the acronyms, the specs and the standards and everything like that are different. And so for the people outside of safety, if you hear safety professionals kind of arguing, they might not even be disagreeing, but because of the difference in perspective and vernacular, some of those times the people just step back from the safety folks and let them go, fight things out, and then off they go. But I'll talk a little bit about that. If you look in the next chart, one of the things I present in my USC class is this scope of engagement. Now, the reason I put that in there is really a practical thing because our class size isn't big, but we pull from very different industries. We've had, obviously a lot of aviation. We've had space people. We've had submarines. We've had surface ships. We've had all these folks from different perspectives come in, and it's helpful for us to know that, their perspective. And so what I ask each student to do is to circle their experience and the whole range. So if they've been in multiple industries and different things, to look at the applications they've worked on, what type of certification it is, who's the operator, what phase of development is it, what's their role in the organization, and specifically where are they in the organization relative to the safety team? Because each one of those can influence how you interact with safety, how you view safety, and understanding that helps us, number one, tailor the course, but it also can explain why a lot of times you have dueling safety experts because they're simply coming from a different perspective. And they're really, if you look at it, a lot of times I hear this infighting and it's really, they're not disagreeing. They're just coming at it from a different perspective. And so the net result, though, again, is that you get people that look at safety and listen to the experts and throw up their hands and go off and do what they want to do. Um, let's go into the next chart, and it's just to show you that's mine. That's my list of where I fall into that. And like I say, every safety professional could fill this out. And I think if you talk to another safety expert you're having a perspective difference with, and if they handed themselves this sheet, I think that would help understand some of the disagreements that seem to exist but really don't. So let's go to the next slide and talk a little bit more again about understanding how we get to this crisis. Is a lot of times organizations look at the safety team as a pool and you can pull them to do anything. And the fact of the matter is really depending on the phase of the product life cycle, the skill sets, the things that the safety department need to do can be vastly different. And each of them can take their own 10-year cycle to learn and become familiar with. And that's what this chart is really getting at. If you look in the top right, it looks at the different phases of development, and it talks about really the scope of the safety team effort, what you're trying to do. And then at the bottom, it talks about the required skill sets. And a good example is when you're in product development, you're going to be having to do the analysis to look at the entire design. You're going to need to do the functional hazard analysis, the system, the subsystem, system, and systems of system, but all these different forms of analysis to understand what your risks are. When you're in the field and on a product, you don't go back and do these types of analysis. You're more or less responding to events that happen. You're responding, I had a field event. I had something that's a leading indicator. You don't do those forms of analysis. And likewise, when you're in the operational sustainment, you're going to have to become an expert in accident investigation. You're going to have to become an expert in fleet risk management. You're going to have to not only know the design of the engine, but how it's being used so that you can assess the risk. And then when you're in development, when you find a hazard, you don't have fielded assets that you have to deal with. And those things have a profound impact on the skill sets of the safety person and also their day-to-day job. And I think in my conversations with folks, I think there's this perspective that I can move safety people around, and you can, but you've got to recognize that there are skill sets that take time and experience and training to do. I think most people understand that, but I have noticed places where that's not held. Excuse me. And the bottom really talks about the bottom right chart talks about the difference between development and operational sustainment. How in a normal safety effort, you start out very different from operational sustainment, but as you go through the process, you actually hand off and become very similar to a sustainment program. You're looking at events that trigger your response rather than doing the analysis because you've already done that in the earlier phases. So really, the understanding the industry should have is that you're not only do you have you need specialized skills, but it really is specialized based on where you are in the product life cycle. Another problem that contributes to the crisis we have in system safety is the fact that there's an effect called the Dunning-Kruger effect, and I think that is a really good one for system safety because what it basically says is that when you start out learning things and you start gaining knowledge, your self-assessment, I'll say, of your expertise can go pretty high pretty fast. And the main reason for that is you know a lot and you're knowing more, but you until you get into it a while, you don't know what you don't know. And then that big decline there is as you go through your safety profession, your career. And I think every safety professional should be nodding their heads is that you go to that point where you realize, wow, there's a lot I don't know. And then over time you actually do get that knowledge and you have the confidence and you can do those things. And the way this plays out is that we know when you need people on the right side of that curve and you've got a lot of safety experts that are on the left side, you can end up with some pretty difficult scenarios that you have to deal with. Some very, very big problems that can come out. It really is what I call there's a high level misinterpretation of system safety that can happen when you're predominantly dealing with folks on the left side rather than the right side of the system safety curve. Um, Again, going back to the idea, system safety is a relative term. I mean, anybody can call themselves an expert, and the fact is there is true expertise. And the downside is a lot of those experts are continually going out of the industry, and like I talked in earlier, where some are getting poached out of the organizations when we need them the most with the specific skill sets you get in safety. So I'm sorry. So the next slide actually just shows the Dunning-Kruger effect slide. So let's go on to one more slide to the next one. And so, kind of in summary to wrap this up is that, the system safety uh, discipline, really, as we know it today, was born out of the ICBM program, at least from my perspective, where we came up with the idea we need an independent safety function providing oversight early in the process in order to manage safety risk most effectively. And we had a great benefit from that. But what happened over time, for many reasons, that function really got subsumed back into the engineering function. In other words, that independence, in my mind, is lost, or it's very fragile, I guess, in the industry. We need a lot more expertise. Um, so, the idea is this crisis is fed by the fact that we number one, we need more safety experts, and that's really kind of the nutshell. Let's go to the next slide. Um, the conclusion of my whole presentation is we're in a crisis mode. We need a concurrence on what the fundamentals are. I know, like I said, I've mentioned the International System Safety Society has had a credentialing program that's going on. They're working that issue. They're reaching out to some universities and thing. But the idea is if we can establish some centralized concept of what constitutes a safety expert, then you get rid of that people on the left side of the Dunning-Kruger effect, uh, you know, contributing to some of the problems. The idea that businesses need to understand that it is a 10-year cycle to create a safety professional, and it's training and it's experience together. It's a long process. You got to be thinking in terms of a pipeline that you constantly have. You put in 5 to get, 2 or 3 safety experts out the other side. And if you're not doing that, then the net experience of your safety organization is just going to drop off. Another thing that I stress in the class, and I didn't talk too much about it, but one of the things that I developed while I was at GE, and really part of that design practice, is a safety process that takes a product from concept all the way through to certification, that takes an approach that isn't saying, how do I convince the regulator that it's safe, but goes back and says, how do you convince yourself first that it's safe? It's the idea that, and I think this was the intent of Mill Standard 882, was the idea that you do this process, you try to identify all the hazards you can possibly think are plausible and you need to address, identify all the mitigating actions to bring the risk into acceptable limits, you implement them, and when you document them, that's the basis of the regulator saying that this is safe. We need the system safety to really work together on this. This is something that needs across the board. And I really applaud the International System Safety Society for really trying to take the lead on that, but it's a tough challenge. The other thing is talking about the C-suite, the industry leaders. If I look at the C-suite and CEO, what position they should have, and number one, like I said before, I think every organization is doing a great job of saying safety is job one. But I really see the CEO and the executive teams as needing to be the health monitors of the safety organization. They need to examine their safety organization, understanding that 10-year pipeline of training, the number of the different things involved with the different skill sets that are required, and understanding the staffing and the training and all those things that are going on, so that you keep a safety team that's viable and ready to go if they're looking at the or safety team and everybody's in triage mode, no one's getting training. Those things should be something that a C-suite or a CEO should be concerned about. And they should also be looking to make sure that the safety teams are being engaged early in the design process, even at the concept level. And if they're not, then that's something that they should hold the safety team to task. And if there's other reasons for it, they're in a position to make sure that the safety team is involved early. And so really looking at the CEO and the executive as really the high health and vitality monitor of their safety team, I think will go a long way to improving this crisis. So I think that's all I had. I think there's a final quote going back to 1947 from William Stiglitz. It's just the idea that everybody should understand the need for an independent safety organization, a safety organization that's trained and has experience and can provide the necessary oversight, so that the everything that can plausibly be done to understand the risk and address it is done. And with that, I think I've got the last slide there. So any questions? There's my contact information if you have any questions. But I believe that if we can address this crisis, I think it's solvable, and I think it's returning back to what the profession really was started out as. And if we can do that, I think we're going to manage risks far more effectively.
Thank you very much, TJ. That was awesome. There's so much we could talk about there. I just want to reinforce to the audience, please, get in touch with TJ, connect with him on LinkedIn. Provide some comments, questions, compliments on this video. That would be amazing. I'm sure he'd appreciate that. But yeah, I just want to say thank you very much. For me personally, this topic is very, very close to my heart. There's so many things you've spoken about that I've personally experienced and suffered from pain and everything else. But there's so many things, and there's a few sort of questions, a few things, a few observations that, if that's okay, I just want to sort of run over and talk a little bit about. So at the beginning, you spoke about your experience at USC. I was very fortunate to attend USC in LA in 2018 on their accident investigation course, and that was kindly funded by GE. So I really appreciate that. It was a great experience going to LA, and one day I'd love to go back. But one of the things that you mentioned is about the sort of spectrum of people that attended your course, and I was just wondering, in terms of which domains or countries have the most mature attitude or culture to system safety, and then an extension to that, which ones have the most mature approach to system safety practice, would you say, if you're happy to say?
I feel like I've got a limited sample set, and it's really one thing I noticed in the industry is that different organizations use different resources for training. I mean, obviously, I'm going to look at, I know like the Netherlands and Singapore and some of those other places use USC and have used USC in the past. So I'd say that, well, they've got a very progressive view of system safety, but it is hard to say. And I'm sure within the US and different places, there's pockets, there are people doing it absolutely correct. And, they're not in a safety crisis mode. But yeah, definitely, from my experience, and I've had a lot of experience with the folks from the Netherlands, and they're delightful. They challenge you, and they're happy to call you out if they think you're saying something that isn't right. But
That's great.
honestly, I love those conversations. When someone really challenges because they're really taking this seriously and trying to understand. And if you don't have the expertise, and I think that's, when you teach and yourself, you also you refine your learning as
Hmm.
well. And so you really do look forward to challenges and people, asking the hard question because, you want to find the answer to that as well.
Well, it goes back to your point about the Dunning-Kruger curve. I think
Yeah.
that concept is so important. I think every safety engineer and, well, everyone, especially
Yeah.
CEOs, should learn that concept because, like you were saying, if you've gone through some experience and you are aware of the Dunning-Kruger curve and you're aware that you've
Yeah.
climbed Mount Stupid and hopefully you're down the other side and learning
Yeah.
some more, but you're always
Yeah.
asking yourself the question: actually, in this situation, am I missing something? Am I
Yeah.
actually on Mount Stupid and I don't even realize it?
Yeah.
And you mentioned earlier on about safety engineers arguing with each other, and
Yeah.
depending where they are on that map that you showed, that might explain why they're arguing. But I'd also add that it also depends on where those individual safety engineers are on that Dunning-Kruger curve,
Yes.
because you might
Yeah.
have an engineer that's really far into, they know what they're doing, and you have somebody else who's just before the peak of Mount Stupid and they think
Yeah.
they know more and maybe they're more
Yeah.
argumentative or direct, and then all of a sudden they tip over that point and
Yeah.
we end up in a situation. So that's brilliant. There were a couple of other questions as well. Where is it? So you mentioned in terms of the crisis, I recognise this. This is, in my experience with companies across the globe and predominantly in the UK, I recognise this crisis very, very deeply. And I think it affects everybody. And I agree that we are starting to see more accidents, more complex accidents. And I think it's going to get worse. But there
Yeah.
are also new ways to have accidents, especially when we start involving complex software and AI, and also
Yeah.
the way that those systems are actually plumbed together. IT systems and things like that. But where would you say that how can I prescribe this? Where would you say the safety process falls down the most across the experience with those various students?
Yeah, really good question, Simon. And it comes to something that I know Dan Strube says this in the class, and I say it too. Safety is a bit more of an art form than it is, a prescribed thing because you really have to adapt. Mail Standard 882 is a great basis, right? And it's a starting point. But if you look at the 200 series tasks of analysis, there's a lot of forms of analysis that aren't on that list,
Hmm.
and as you know very well, the SDPA and other forms of analysis are very important and absolutely vital. And as we get more complex, even more vital to understanding. And the fact that it's not an 882 may tell, someone who doesn't have a lot of experience says, well, you can't do that, and it's like, well, you really have to in this complex world. We need more experts and more. I'll say safety artists. There's a
Yeah.
there's a guy that we know that's active on LinkedIn, Simon Danucci, who's the safety artisan, which is
Oh
a
yeah.
wonderful wonderful man. I've assigned on his courses, and he's fantastic. He has a way of speaking that both you and he are kind of similar in that you present way better than I do, but really emphasizing the fact that you really have to take an approach that you have to be creative. This is not a cookbook. This is not a Betty Crocker recipe, and you to be effective, you've got to flow with the changes. And that's why when safety people can't attend seminars, can't attend, never mind the basic training, but if they can't attend continued training, you're going to fall back because
Yeah.
that's where you're going to find the hey, I learned this. I mean, one of the great things when I meet with fellow safety professionals, and like when I meet you, we smile a lot because we have these four mini support groups because we kind of are up against the same thing that we all have, and that this is something that takes expertise and time to do. And the experts, once they know it, they are willing to share it. You've been very helpful to me. I know before I retired, you came to GE Aerospace and gave a presentation, and it's out of a heart for really, there's a passion really in most people that have been in safety a long time. Like I say, sometimes it can work against them, that
Yeah, yeah.
if it's misplaced passion. But by the same token, I always tell people we have the high calling that we're just trying to save lives. I think that's a thing. But yeah, I think the artisan aspects, the fact that really an expert is someone like you say in the far right of that. And another byproduct of that is unfortunate is that you have a lot of people that are really on the right side of that expert curve, but are unwilling to call themselves experts and share their knowledge. That's why I'm so appreciative of the folks. And I'm a part of the virtual chapter of the International System Safety Society, and we have a number of folks, that they were doing safety, way back in the early era. So it's their input, their perspective is incredibly valuable and very precious, and we need to make sure we capture that.
We'll have to invite them on. Have a
Yes, yeah,
conference
wait,
and get
yeah.
everyone together
Well,
and
I know that some of
capture it.
them will be sending the link to this, and so we'll
Yeah,
we'll
yeah.
get some of their comments. But
Yeah, well, come
I
along.
just
Share the
yeah,
experience.
maybe we'll do more podcasts there. You
Yeah.
can be the Joe Rogan of system safety and bring us in and have us have the
Well, I've got
discussions.
the haircut for that. I think I'll be.
You do
Um, so there's a few other questions then. You
certainly.
mentioned about safety team involvement, and often it's quite late. And you
Yeah.
also mentioned about the movement or change in the organisations between safety engineering being part of the engineering organisation and being moved outwards, so it was more independent. And then there's a trend to bring that back together again.
Yes.
Um,
Yeah.
what would you say is the biggest challenge or the biggest blocker for engineering organisations involving the safety team early?
Um, it's compounded when if they have brought safety people in at the conceptual level
Hmm.
and they don't have much experience and they just sit there with their, on their hands and they can't contribute, that gives the engineering teams a dim view of safety. And I think
Yes.
that's the problem is, when you get, as the industry gets younger and you get more people on the left side of the Dunning-Kruger effect, they don't represent safety well. I mean, no, good intentions and I know I was calling myself a safety expert probably long before I really was, but by the same token, practicality was there was no one else to do it. But it puts a sour taste, I think, in the engineering people's minds that, well, here's this person that's critiquing my stuff, and they don't really have, the stuff needed to provide input. So, but
It's a huge challenge. I mean, my sort
yeah,
of from my personal experience and been sort of open and vulnerable, my sort of personality profile can be quite direct and task focused. And 15 or so years ago, and doing safety work, you sort of view yourself as, well, we're here to do safety. What, surely you want to help us help, make the system safe. Why are you trying to resist us? Why are you not involving
yeah,
us? What's the problem? We're all sharing the same end goal, which is to make the product or
yeah,
service safe. And if you come across in a certain way, more direct or more sort of argumentative, then obviously that's not going to work. And as a young
yeah. They're
safety
going to want
engineer,
to
I
push you
didn't.
out.
Well, this is it. I didn't necessarily appreciate that, and then over time, as I've got more wiser, so to speak, more
Yeah,
experienced, and worked on myself, recognizing that the ego is the enemy, as
yeah,
various philosophers have written over the years. Having that self-awareness and developing that self-awareness and being humble or working to be humble and
yeah,
recognizing where we are on that Dunning-Kruger curve, I think is a
yeah,
fundamental part of being a good safety, being a good safety engineer, being able
yeah,
to reflect that and understand emotionally how we fit into it and how we should approach problems. But again, that takes time. You can't
yes,
just roll out of university with a degree and be a philosopher engineer, so to speak. It takes time. It takes personal dedication to be on that path on that journey, and not everybody is willing or prepared to do that. So it's, that is a challenge. There was a few other things that I really liked. You mentioned the 10-year rule, and that if you do a safety job, you should be expecting to be there a long time, so that you can develop those interpersonal skills and technical skills and safety skills, and also build that trust and respect in the organisation.
Yeah.
Why do you think it's 10 years? And when I say 10 years, would you say that that's 10 years in one place on one project? Or would you say that that's 10 years on many projects, many organisations, many parts of the life cycle?
Yeah, I would probably narrow it down by 10 years in the product life cycle, right? 10 years in development, you're going to be able to do that. 10 years in operational support, because the skill sets are different. I think, once you start talking beyond that, then you are malleable and you are movable and you have skill sets. I mean, there's some folks that are just really sharp technically, and they can come in, they can be an accident investigator really quick. They can understand system hazard analysis and all that really quick. But, then you need the experience piece. But yeah, as far as the 10 years, I'm not sure where that came from. It was just, one of our the heads at GE Engineering, and she went on to become the vice president of engineering, and she actually made some great statements, and she put out a thing that said every engineer is a safety engineer at GE, and I think that was a laudable way to do it. But you can't do that at the expense of your safety department. You can't say that everybody's a safety engineer, so now I don't need safety engineers.
Well, yeah.
And I'm not saying they did that, but I think that's the risk. It's kind of like when I get nervous when people talk about design for safety, and it's like, well, you do design for safety, but you can't say, well, I don't need a safety department now because I understand how to design for safety. That oversight need is still there. And,
absolutely agree with that. Well, let me capture a couple of others. Let's have a look. What would you say about the statement, compliance is not the same as safety? Or the statement, compliance is safety? What would you say about that?
I would twist it a little, and I would say blind compliance is not necessarily safety. And in some cases, like I talked before, where safety people are their own worst enemies, we've had people that just rule with an iron fist. I have a whole series of articles I did on LinkedIn called the S word.
Oh, the S word.
When you bring the S word in and you say safety, people listen. Like E.F. Hutton, and a lot of people get a hold of that banner, and they're not afraid to swing it around the room. And the unfortunate thing is, how that's played out in a lot of reports when I listen to people who have been wounded by their safety teams has been that, this guy coming in and, swinging the axe and making sure, well, this is what you're going to do without being able to explain, there's a reason for that. And being able to have enough knowledge of the fundamentals or why that thing is there. And also to know that we can probably move past that and say, well, here's why we can accept the risk of not complying with that. But it takes, goes back to, it takes experience to be able to do that.
Absolutely. Thank you. You mentioned about the different states of the safety team. So you can have business as normal, day to day, like a doctor's office, a GP office, or it can be like an emergency department, emergency room, or accident emergency. And moving between those states is obviously dependent upon, what's going on in the organisation and what's happening in the field, if that's what they're doing. And you mentioned that a rough stat, finger in the wind probably, of 30 to 50% of effort is unplanned reactive effort. And I really like that sort of observation. But in my experience, especially relatively recently, I would argue it's probably more 80 to 90% of firefighting reactive effort.
Yeah. You're just more bold than I am, but I think the same way. I just wasn't willing to say it.
No, that's fine. And that sort of goes back to one of the last statements you made was about moving from blind compliance to working to convince yourself, not just the regulator, but convince yourselves that the product, service or system is safe first. And that sort of struck a chord because that relates to, in the UK context and some other industries across the globe from a safety case perspective.
Yes.
I don't know if you're familiar with safety cases or been involved in developing safety case or reviewing safety cases, but I
Yeah,
know
no direct involvement.
no,
I understand it. But part of
yeah,
my so I worked on two completely different designs for the F-35. The first one was the 136 design, which had a lot more engagement with the ministries of defense.
yeah,
And so when I was formulating the hazard tracking system and the reporting, I actually made efforts to try to comply to safety case in the sense of building the arguments and everything for at the hazard level. And I never got a chance to submit one or find out, but I understand safety case. I think it's a brilliant way to express not only what the hazards are, but what you're going to do about them and why why this is safe. Convincing yourself first. But no, I don't have any direct experience with it. And I hope maybe in time I will. I really say that when I in the tool that I wrote, I had the opportunity to make it any way I want,
yeah,
and so the final reports that come out of that report, I believe are structured towards safety case.
yeah,
Because really, if you look at the reporting in 882, I think it's task 301 when they talk about safety assessment reports. There's two DIDs for this that meet the requirement. One is called a SAR, Safety Assessment
yeah,
Report, and one of them is a System Safety Hazard Assessment Report. And so I had contracts where I had to write both for different reasons. And when I wrote the SSHAR, the way I interpreted it, the SAR was a snapshot that you use to say, well, first engine to test, first flight,
mm,
all the hazards relative to that specific aspect are addressed, and here's why it's safe to go fly. But the SSHAR was for the whole thing, and
mm,
when I wrote the report for that, I wrote it with a safety case mindset,
mm,
but like I say, never got a chance to deliver it
yeah.
um,
Well, that
before
was
my retirement.
the reason I highlighted that was just because I was thinking in terms of maturity or evolution of time. So if you start with a basic safety is about compliance with standards and regulations, and everybody wants to or should want to go further than that and
Right.
overachieve if you like, and moving to the concept of convincing yourself that the thing is safe, the product, service or system is safe. And then naturally, how do you go about demonstrating that it is safe? Sort of
Right.
a maturity level above that. And safety cases sort of fits into sort of covering all three of those. But what I've found in my experience, and Nancy Levison is not a supporter of safety cases for various reasons, and I totally understand where she's coming from, and I agree. But also, it's this other side that if you are required to go down the path of trying to explain, justify, and demonstrate, in theory, that's a good thing. And it should be supported. But where it falls over, where it falls flat on its face, is where organisations or safety managers, they focus on, like project management, a task list of, well, we need to deliver these documents by these milestones. All of a sudden it becomes about documents and deliverables, not actually about doing the safety engineering work and then,
Right.
trying to create a safety case from that. And I think that, whilst it's not mentioned in your in your presentation, for me, that is one of the biggest challenges that
Yeah.
contribute to that crisis. If you've got people, on the left-hand side of that Dunning-Kruger curve who, they've been asked to deliver a safety case, so that's what they're delivering.
Right.
That's not necessarily the same as delivering a safe product, service, or system that's actually had proper
Yeah.
safety engineering process
No,
applied to it. So, do you have any comments about that, or any
no, that's a
thoughts
that's a
about that?
brilliant observation. And like you say, if you're on the left side, you're a new, minted safety engineer, and you're given a development program. The temptation is to just go to the contract, look at the deliverables list, and then work backwards to say your
Yeah,
safety program to meet it. And it's an unfortunate reality that happens a lot. But
yeah,
yeah, I mean, one of the things why I'm retired and still doing this is
yeah,
I'm hoping to show by example. In the course I teach at USC,
mm,
I take an example program from concept all the way to certification, and in doing that, the reaction I've gotten from folks is that that's easier,
yeah,
than going taking a look at the deliverables and figure out how do I write an SSHA or an SAR.
Yeah.
Let that be a natural outcome of the process that you follow.
Mm.
And by the way, if you do that process right, if you know how to read Mill Standard 882, it's it's doable. For each engine program I worked, we had anywhere from 12 to 20 engineering teams I had to interface with,
Wow.
and a whole bunch of people. And so I got a lot of reactions from folks, and a lot of times a lot of hostility because
Yeah.
this is, oh, I got to attend a safety meeting on top of everything else.
Yeah. Yeah.
But the common reaction I had from my engineering teams was, there were some that were absolutely accepting and they ran down they took the ball and ran, and others like fought tooth and nail. But the ones that fought tooth and nail all of a sudden came when we got to the end. It's like, this is easy. I
Yeah.
see what you're doing. If you can, like I talk about it, the safety process during development should be in bite-sized chunks.
Mm.
And if you get involved early enough in the process, you can set that up and it becomes really painless to go through. I think when we did on the XA100, we did an average of the safety meetings were 1 to 2 hours a month. I mean, some of them had higher because they had a higher caseload, but I mean, it wasn't. If you got involved early, you could do that. I mean, if you get involved too late, well, you got to compress all that,
Yeah. Yeah.
and you're just you're not, like you say, you're not focusing on convincing yourself first. You're focused on making the deliverable.
And that sets up something that's, I think, could be brought out a bit more, is about the personal aspects of it, the personal costs in terms
Yeah.
of stress and well-being. If you're not necessarily that self-aware, or you're not so advanced with managing stress, that can burn people out. Because safety
Yeah.
engineers are trying to do the right thing, but if you're working with a hostile project or hostile project manager, that can make it all the more worse and lead to burnout and staff
Yeah.
turnover. And
And that's
you mentioned about health vitality monitoring of the safety team. I'm absolutely 100% behind that. I'm absolutely convinced, if whoever is listening to this that's involved in safety management, talking to the CEO or the board of directors, whichever high level people you're talking about, if they don't have a feedback loop from the system safety team that
yeah.
is a candid feedback perspective about resources, workload, behaviors, cultures, all of that good stuff. If you don't have that feedback path, you could be having, you're on the way to a disaster without realizing
Yeah.
it. So implement that feedback path, listen to your safety engineers, find out how they're doing. If they're all
Yeah.
stressed or you can't recruit them, especially if you can't retain people, there's a bloody good reason for that, and you should be paying
Right.
fast attention to it. So I'm really
Yeah.
glad that you highlighted that. That was fantastic.
Yeah, when I gave this presentation at the ISSS conference, there was a keynote that came after me, and you saw that I had mentioned the role of the C-suite in this,
Yeah, yeah, C-suite.
yeah, and so when NVIDIA, who does the chipset for the self-driving cars, gave a brilliant presentation on their work
Oh,
in the
fantastic.
system safety realm, or functional safety realm, as they characterized it. They had at the end, they said, we have 5 key lessons learned that to the safety effort. Number one was engagement of the CEO.
Yeah,
Yeah, and they said that's the reason they were so successful. I mean, the man years of effort that they were able to put in because they had the support and doing it. I mean, just a wonderful presentation. But I remember, jumping up and down thinking, thank you,
yeah, fantastic. Finally,
Yeah.
that's
Like I
amazing.
say, when safety experts get together, it forms a little bit of a support group, as we
Yes,
say.
yeah, yeah, oh,
You
yeah.
know what they did to me?
Yeah. Yeah, I'm sure there's a lot of people listening to this that are nodding along going, yeah,
Yeah.
you
Yeah.
get a load
So
of safety engineers together, some of the
yeah,
stories.
but it really is the reality that there's a necessary component to
Yes.
us getting together, and that
Oh,
is
yeah,
because, like you say, that hey, the world's advancing at a high rate, and if we're not keeping up now, it's not going to get better unless we take some proactive steps to do that, to address it.
absolutely. Well, just one sort of final question. I'm just curious. As a bit of a plane spotter,
Yeah.
having worked at the Royal International Air Show and attended quite a few, the aircraft behind you, the F-16 with TJ
Yeah.
on the tail. Tell me a little bit about that, and also just from a weapons perspective, is that a B-61
No,
eyes
no,
deceiving
I'm
me?
pretty sure no, that's not it. So yeah, during Desert Storm, the early part of Desert Storm, they based a bunch of GE powered F-16s in Torreon, Spain,
Oh
and
wow.
so it put TJ on the tail. And I remember the first time actually one of the first times I saw it was a picture of just the tail section that had been shot off of one.
Oh,
It wasn't quite a great
okay.
introduction, so I naturally for my screensaver I chose one where everything's put together. Yeah, I'm not sure what block that is, but
Yeah,
yeah, there's a lot of guys in our program that could tell you more about that. I just know I can just look at the tail feathers, the
yeah.
end part of the engine, and tell.
That's awesome. Well, I just want to say thank you so much for taking part and sharing your experience and your passion for system safety. As we've already said, please get in touch with TJ. Give him some abuse on LinkedIn. Connect with
I
him
can
on
take it.
there. And of course, if there's anything in this presentation, this conversation today that strikes a chord, please comment below, share your experience, and if you'd like to come on one of these, pseudo podcasts for system safety, perhaps
Yeah.
we could arrange something in the future. But I just want to say thanks again, and
Yep.
take care. Thanks very much.
And thank you, Simon. Have a good night.
No, you're most welcome. Thank you.